Okay, this is hello everybody. This is going to be the last lesson for our algebra unit, factoring polynomials. After this, there will be a review video, and then possibly we will be having some kind of prep for right before the assessment, but it depends. We're not sure, again, what the evaluations are going to be. More information will be clear at the end of next week when our official break ends and then our extended break begins, which Mr. Tremoli will be and I will be in touch with you regarding that very soon. By next Monday at least. But without further ado, let's get started on factoring polynomials. So a factor is a number or a term that divides evenly into each term of the polynomial. So now, what does this mean? So when we talk about factors, basically what we want, so let's say I have, for example, the number, 15. When I say a factor, I want to represent 15 as a product of two terms. So I want to say like 3 times 5 or 1 times 15. And just like that, I want to do this with polynomial expressions. Now, there's a couple of important differences between doing it with numbers and doing it with polynomials expressions. One, numbers is just one number. So like 15 is like 3 times 5 or 1 times 15 or etc. But polynomial expressions have like plus signs in them. So they're composed of multiple terms as opposed to a number, which is just one term. So we have to be a bit more careful here, but ideally what we want is we want to represent 5x squared plus 35x as basically the product of two different terms. We want to split this up into its factors, so to speak. Like, give me two things that multiply and leave me with 5x squared plus 35x. So now, the way to do that is using a trick that we learned, or a tool that we learned in the last lesson, was just to find the greatest common factor. Whenever you're asked to factor stuff, you often want to find the greatest common factor of the thing. It could be there could be a chance where you could factor this in different ways. Technically, just like you can say 15 is 3 times 5 or 1 times 15, you could factor this possibly in like two different ways. But we're going to be focusing on the way that involves the greatest common factor, just because it's a standard method to use throughout and there's no confusion. So first thing we do is find the greatest common factor of basically all the terms in the expression. So again, the entire thing is an expression. Individual things that are separated, individual terms that are separated by plus or minus signs are the terms. The definition, if it's separated by a plus or minus sign, it's a term. So this is a term, this is a term, the entire thing together is an expression. We want to find the greatest common factor between all the terms in the expression. So we want to find the greatest common factor of 5x squared and 35x. So hopefully we will recall how to do that. From last time, first find the greatest common factor for numbers. So that's a 5 and a 35. We'll note that the greatest common factor is 5, because this is like a 1, 5. This goes, that has to be the highest. There's only another trick, I think, to finding the greatest common factor is always start with the lowest number, because we know that the greatest common factor, whatever it is, it cannot be more than 5, because the factors of 5 stop at 5. So whatever it is, it cannot be more than 5. So check all the factors of the lower number. 1 and 5, and that 5, I see that 5 is shared. 5 also goes into 35, so 5 is the greatest common factor with respect to the numbers. Again, I'm hoping that's like mostly review. You know how to calculate greatest common factors. And again, with the variables, I see an x squared and an x to the power of 1. So the greatest common factor would be the lower power. So the x to the power of 1 is the lower power, so that is the greatest common factor. This greatest common factor is one of the terms in our required product. Again, we wanted to express this expression as a product of two different terms. The greatest common factor is one of those terms. Now, the question is, what is the other term? The other term is what happens when you divide out the greatest common factor from the expression. So let me explain what that means. So let's say I have something like 16. That's a bad example. Let's not do 16. 20 plus 45. Now, just to illustrate how this would look like a variable, I'm going to illustrate how it looks like with numbers. I know this is just equal to 65, but we're going to try and express this as a product of two different terms just by using the method of greatest common factor. So again, I want something that looks like two brackets, and the first bracket, the monomial, is always going to be my greatest common factor. This is always going to be a rule in factoring. So the first bracket has to be my greatest common factor. So what is my greatest common factor? Again, start with the factors of the lowest number. We have 1, 2, 4, 5, 10, and 20. So now check which ones are common with the other one. So 20 doesn't work because it doesn't go into 45. 10 doesn't work. That doesn't go into 45. 5 goes into 45. So 5 has to be the greatest common factor. So this here, instead of greatest common factor, we're going to write 5. And then what goes inside this other bracket? I'm going to divide, just like, it's basically division. I'm going to take out a 5 from each of these terms. And when I mean take out, I don't mean subtract. I mean divide out a 5 from both of these terms. So we're going to use the term divide out a 5 from both of these. That's what I meant. We're going to divide out whatever greatest common factor we had from both of these terms. So let's see, we're going to divide out the 5 from 20. That leaves us with a 4. Divide out the 5 from 45. That leaves us with a 9. And we get 5 times 13, which, as we know, is 65. And this is just confirming what we said before, that 5 times 4 plus 9 is indeed the same as 20 plus 45. So this is just saying that we're not really changing the question. We're just expressing 20 plus 45. Instead of a plus sign, now we have a multiplication sign between two different brackets, right? And this is helpful for many things. If we have multiplication signs, we could perhaps do some cross canceling that we could not have done before. And this is essentially why we're learning factoring. It's going to be hugely important in pretty much every math course you take from now on. But moving back to our question here, we have already determined that the greatest common factor here has to be 5x. And you'll notice I did 5x squared divided by 5x, gave me my x. 35x divided by 5x gave me positive 7. That's how I got the second bracket, x plus 7. I divided the expression by the greatest common factor. I divided out the greatest common factor from my expression. So hopefully that's okay. We're going to try another example. Now this example is a bit more interesting because we have already been given the greatest, so the first bracket has been given to us, the greatest common factor. Because it's just one term, it's not necessary to put it in brackets. For example, it's important to use brackets when you have like a binomial times a binomial, so that we know we have to use like the crab claw method to multiply it out. But if you just have like 3x squared times x plus 3, you could put this in brackets if you wanted to, but the brackets aren't really necessary because there's only one term to multiply into. So that's why we generally don't put the greatest common factor in brackets. If you do, there's nothing wrong with doing that. So again, a hint on how to find the greatest. Hopefully we can see that the greatest common factor between 16 and 8 is just 8. I have an x to the 4, x to the 2, so x to the 2 becomes part of my greatest common factor. Y to the 2, y to the 1, y to the 1 becomes a part of my greatest common factor. So I have established my greatest common factor, it's already given. And now I have to divide out the greatest common factor from each of the terms. Just like basically what you're doing is 16x to the 4y squared divided by 8x squared y. minus 8x squared y divided by 8x squared y. Whatever, divide each of the terms by the greatest common factor. Here we can see that we have a 2, 4 minus 2 is 2, 2 minus 1 is 1. That's what happens when I divide this by my greatest common factor. And then here I get 8 and minus 8 give me negative 1. 2 minus 2 is 0. 1 minus 1 is 0. Anything to the power of 0 is 1. I'm not going to write it. So this becomes my answer. Sorry if that's a bit messy. 8x squared y, 2x squared y minus 1. A good note, if you do FOIL, you don't have to, sorry, not FOIL. If you do distributive property to this bracket, so let's go back to this example. What was our answer? 5x times x plus 7. Let's say we were expanding this. 5x times x, 5x squared. 5x times positive 7 plus 35x. We get back the original expression. And this is always a good way to check if you've done the factoring correctly. If you expand, you should be able to get back the original expression. Just so we're going to learn two contrasting terms now. Factoring is basically the opposite of expanding. So this is important to understand exactly what a question is asking you to do. I should say not interchangeable. Whoops, opposite. To factor things, we want to put stuff in brackets. We want to express things as things that are multiplied. I keep saying things. We want to express expressions as the product of two different brackets, right? That is factoring. Expanding is we want to get rid of as many brackets as possible. We want to get rid of brackets by multiplying into the bracket. We want to expand the bracket. So that's how factoring and expanding are like opposites of each other. So basically when you factor, you go find the greatest common factor and then you divide that out from the original expression to give you two brackets. If you're expanding, you want to multiply the monomial into the binomial to get back the full expression here. So again, even if you did this expansion, hopefully you'll see that you'll get back the original expression there. So find the GCF of all terms in the polynomial. So we're going to find the greatest common factor of all these terms in the polynomial. And then determine the other factor by dividing each term by the greatest common factor. We're gonna do that right now. So again, hopefully I've not made that abundantly clear in the previous videos. When we're factoring, we find greatest common factor between the two terms, between all the terms basically in the polynomial. If there's more than two, then so be it, but we're going to stick, I think, to a maximum of 3 I see over here, but not more than that, hopefully. Okay, where were we? 10x minus 20. Okay, greatest common factor. Hopefully we can, again, we have 1, 2, 5, 10. Those are the factors of 10. Check the highest one. That multiplies into 20 perfectly, so 10 is my greatest common factor. I have x and I have no variable, so there's no variable that I can factor out because there's no variable here that is common with anything from this term. There's no variables that are common. So 10 is the only thing in my greatest common factor. So I put my 10 over here and then I open the bracket. And then what I have to do is divide out the 10 from each term. So 10x divided by 10 leaves me with an x. Negative 20 divided by 10, negative 2. And this is my answer. This is me factoring this expression completely. 22x minus 99y. 22, let's see, 1, 2, 11, 22. 22 doesn't go into 99. 11 goes into 99, so that is my greatest common factor in the number part. I have an x. I have no x variable here, so that cannot be part of my greatest common factor. I have a y in this term, but I have no y variable in this term, So again, that cannot be part of my greatest common factor. The key word there being common. I have to find a variable that's common to both these terms, and there is no such variable. So 11 is my only, 11 is basically the extent of my greatest common factor. Divide stuff out, 22x divided by 11. 2x. Negative 99y divided by 11. Minus 9y. And this is my final expression. X squared minus x. Now this is an interesting case. The greatest common factor here, we don't have to worry about numbers. There's no numbers 1 and 1, so basically they can be ignored. Let's look at the variables. I have an x squared and an x. Again, the greatest common factor is going to be my lowest exponent, so an x. Now let's see what happens when I divide out an x from each term. X squared divided by x. 2 minus 1 gives me x to the power of 1. Negative x divided by x is just minus 1. And this is my answer. And hopefully we're doing this check to see x times x, x squared, x times minus 1, minus x. We can see that if we were to use our rules of distributive property like before, we get back our original expression, which is what we want. Okay. Again, I could give you some time to go over these, but hopefully. Actually, I'm going to take a moment and say, you know what, pause the video if you haven't done so already. Take a look at these other questions. See if you can try them on your own. Try DEF, so I won't actually wait for the time because I'm assuming you're going to pause the video. But again here, greatest common factor would be an m. And here we can kind of take negative m squared divided, my pen's being, nope. Negative m squared divided by m is negative m, and positive m divided by m is just plus 1. This is an acceptable factoring because you say, okay, I have an m squared, I have an m. The lowest power there is m to the power of 1, so that becomes my greatest common factor. And also acceptable way to factor this, just like I said, there's multiple ways to factor this. There's technically 2 right ways to factor this. You could take the greatest common factor as negative m, as in you could factor out a negative sign along with your greatest common factor, because the negative is part of the highest power. Now that's, again, practice that we don't see become like a rule until we get to grade 10. Technically, this would be correct, but again, on a multiple choice test, this option may not be provided. You'll only be given this one, and it's important to know that this one's correct. So if we did factor out a negative, let's say our greatest common factor was negative m. So I did negative m squared divided by negative m. So the negatives cancel out, right? Negative divided by negative is a positive. M squared divided by m is positive m. And then plus m divided by minus m would give me negative 1. Hopefully we're okay with that. So this is also an acceptable answer to the question. So again, either one works. So moving on. Again, see here we have an interesting case where we have hold on a second. Sorry about that, technical difficulties. We're going to look at the numbers here, negative 10 and negative 25. So here we see that the 10s are 1, 2, 5, 10. The 10 doesn't go into the 25, but the 5 does. So 5 is our greatest common factor number-wise. But I also see that I have a negative sign here and a negative sign here. So that is also something that's common between both of the terms. So I can take a negative 5 out. The negative becomes part of my greatest common factor. But my greatest common factor is not technically done yet because I haven't done the variables x squared and x to the power of 1, that the lower number becomes part of my greatest common factor. Now time for division. Negative 10x squared divided by negative 5x gives me 2x. Negative 25x divided by negative 5x gives me plus 5. Alternatively, if you didn't take the negative out and you just said your greatest common factor is 5x and you did the division, you would get negative 2x minus 5. Again, this answer, I believe, for grade 9, this will be acceptable, but you have to know, given a multiple choice test, that this is also the correct version. It is proper form, I will tell you now. Going into grade 10 and grade 11, it is always proper form to factor out a negative. If your highest power term, the x squared would be the higher power, is negative. If that is negative, you want to factor it out so that I get a nice 2x inside the bracket. I don't like my bracket starting off with a negative. That's just proper form. It is good to factor the negative out if you see that happening. And it's also important to know that that is also an acceptable correct form for this question. Now let's look at this one. 13a plus 12b minus 4c. Let's find our greatest common factors. I have a 1, 2, and a 4 going in with the 4 again. I start with my lowest number. The 2 goes into the 12, 4 goes into the 12, but 2 does not go into 13, 4 does not go into 13. So basically, my greatest common factor has to be common between all my terms. And so this 13a, there's no number that's common between 13, 12, and 4. There's no factor of all those three numbers, except for 1, which I can ignore. And my variables are also all different. So therefore, the greatest common factor here would just be 1. The number 1, and there's no variables. And then if I divide this, obviously I'm going to get the same things. There's no, hopefully there's no doubt about that. And here you can see that the 1 times this is basically this. It's not possible to factor this question. All right, such questions will occur, so it's good to be wary of them, and don't be surprised if it happens like that. Just hopefully nobody got too stuck up on that question when they were trying it. Okay, let's look at this. 12 and 8. I go 1, 2, 4, 8. 8 does not go into 12. 4 goes into 12, so that's my number part. X squared and x. I'm going to take an x. Y squared and y. Take a y. Z, z. I can take a z. Let's do division. 12. So this divided by 4xyz, and this divided by 4xyz. So 12 divided by 4 is 3. 2 minus 1 is 1. 2 minus 1 is 1. 1 minus 1 is 0. So I can ignore that. 8. It gives me a negative 2. 1 minus 1. 1 minus 1. 1 minus 1. All x, y, z have a power of 0, which is 1, which is equal to 1, so I don't have to write it. So this is my factored form. Okay, let's take a look at this. 4. I go 1, 2, 4. 4 goes into 8 and 16, so I can take a 4 out. But again, I'll notice here, hopefully, that my first term here with the x squared, which is the higher power, is negative. So I am going to factor out a negative 4, even though both of these terms are positive. You always go by whichever term has the highest power. That kind of gets priority. So I am going to factor out a negative from the 4. Again, now we're going to look at the variables. I have an x squared, but I have a y. So I don't have any, again, if you look at the x, I have an x squared here, an x here, but I don't have any x in this term, so I can't factor anything out. Same thing for the y. I have a y here, but I don't have any in these two terms, so I cannot factor a y. Again, Common factor means it has to be common among all terms in the expression. So let's do division. Divided by -4 is 4x squared. Divided by -4 is minus 2y. Divided by -4 is minus 1x. If you didn't factor the negative out, you would get something that looks like this. And again, it's not proper form to start your bracket off with a negative. It is proper form to write things in, decreasing order of power. So you always want x squared and then the x and then the y, or x squared and y and x. If they have the same power, the order doesn't really matter, but the x squared should come first. And I don't want to start my first term with a negative, so proper form would indicate that I do factor out the negative. Again, if you haven't tried this one, I'd give it a try, so pause the video. I'll give you a couple seconds. But again, the greatest common factor here would be, there's only two factors for this, 1 and 7. 7 goes into 21 and 35, so 7. Now let's take a closer look at my variables. A to the 4, a to the 3, a to the 2. I'm going to take the lowest one, a to the 2. B to the 3, b squared, my lowest one being b. That is my greatest common factor. I now open the bracket and I start dividing everything by my greatest common factor. We'll see here 35 divided by 7 is 5. 4 minus 2 is 2. 3 minus 1 is 2. Minus 3. 3 minus 2 is 1. 1 minus 1 is 0, so ignore that. Or b to the power of 0, I should say. Plus 1. 2 minus 2 is 0. 2 minus 1 is 1. And this is my final answer. This has been a long lesson, so we're just going to take a quick look at the homework, which is, there's no textbook work, it's just, sorry. Can I turn this? Probably should be able to. Go away. No, that didn't work at all. My bad. A rotate button. Oh well, I can't find it. It doesn't really matter. If you would take a look at the homework. Let's see. I want you to try, for me in the question section below, try set 4 questions D and E. These are the 2 questions I want you to try. I know you've hopefully done all the homework, but I want you to post an answer to these 2 questions in the comment section below. So that would be your homework assignment for this lesson. And congratulations, we have successfully, despite all the stuff that's going on, finished the algebra unit. So pat yourself on the back. Good job, guys, and girls, of course. We shall now start to think about assessment, because we won't be back, of course, for the foreseeable future. We are going to be doing at least some of our unit assessments online. Otherwise, we'll just have too much work to do when we get back. So we will be in touch on that. So I'm signing off right now. Peace out. Good luck. Stay healthy. Stay safe.